Welcome class. In this lecture we are going to continue with the Laplace transform series. In the previous lecture we have studied the Laplace transform of some of the elementary functions. Now we are going to the topic called properties of Laplace transform. Laplace transform. Before I derive those properties, let me put them in clear words. That if Laplace transform of ft is equal to f of s, then Laplace transform of e to the power at ft is equal to f of s minus a. This is our claim. Now I will simply derive it with the fundamental definition. We know that the Laplace transform of ft is equal to 0 to infinity e to the power minus st f of t dt. Using this definition, I will now write the Laplace transform of e to the power at ft. This is our 0 to infinity e to the power minus st ft, and not to forget e to the power 80. Now this is 0 to infinity. If we can write it as minus and s minus a, and we are taking the common as t, and we can definitely write it like this, ft dt. Now we are seeing here the Laplace transform for ft is equal to f of s. Okay, so this is the s. So whatever is the coefficient of minus t, that is the transform. Similarly, here the coefficient of minus t is s minus a. Hence, we have proved the property number 1. So this is called shifting property. Similarly, what will be the Laplace transform of e to the power minus at ft dt? That is going to be f of s plus a. I think without loss of generality we can write it like this, and if we would like to derive this one, we can do so. Let me derive it for you. Laplace transform of e to the power minus at ft dt is equal to 0 to infinity e to the power minus st e to the power minus at ft dt. So this becomes 0 to infinity e to the power minus s plus a t ft dt. So we have just now studied whatever will be the coefficient of minus t, that will be the transformer. So this is again the shifting property. Now the next property that we are going to study is differentiation property, which is very critical for civil services examination, and a lot of questions has been asked on this. If Laplace transform of f of t is equal to fs, then Laplace transform of t to the power n ft is equal to minus 1n dn by dsn f of s. This is the property. Okay. Now we will derive it. We know that f of s is equal to 0 to infinity e to the power minus st ft dt. Alright, this is the reverse equation. LHS and RHS are reversed for the Laplace transform. Now we are going to take the derivative with respect to s, 0 to infinity. Here we are going to write dou by dou x e to the power minus st ft dt. Now this is the Leibniz rule we are using, differentiation under the sign of integration, which we have studied in calculus. So what we can write it over here is e to the power minus st, and its derivative is minus t f of t dt. Now if we take this minus sign on the left hand side, that becomes d of fs ds minus is equal to 0 to infinity e to the power st p ft dt. Now this is the Laplace transform of t ft. Okay, we can reverse this equation and we can write it Laplace transform of t ft dt is equal to minus d of fs by d of fs. This is for n is equal to 1. Now we are going to use it for n is equal to k using the mathematical induction. So for n is equal to k, what it will be? T to the power k ft is equal to minus of k dk by dxk f of s. Alright. Now we can write this equation as reverse of this, dk by dx of k f of s is equal to Laplace transform 0 to infinity e to the power minus st t to the power k ft dt. Now what we do is we again take the derivative with respect to x. So what it becomes? D k plus 1, and again we are taking this here, and now again we are introducing the sign of differentiation derivative t to the power k ft dt. So what this becomes? This becomes 0 to infinity e to the power minus t. Again this becomes minus of t tk ft dt. Alright. So we multiply this side with minus 1. So what it becomes? Minus 1 into k, 1, so it becomes k to the power 1. So dk plus 1 d of s k plus 1 f of s is equal to this minus minus become plus. So 0 to infinity e to the power minus st, and this become t k plus 1 f of t. So this is our claim, and we can write it as Laplace transform of t plus k plus 1 ft dt k plus 1 dk plus 1 dsk plus 1 f of s. Alright, so we are seeing for n, for k, n is equal to k plus 1, it is also true. So hence by mathematical induction we can say that we have derived this property. Just now we have studied this property of t to the power n ft minus 1n f of s. Now we are going to take one example. We have to find the inverse Laplace transform of ln x plus 1 by x plus 5, and this question is asked for 20 marks in Civil Services Examination 2009. Just now we have studied this property. First of all, we write f of s is equal to ln of s plus 1 s plus 5. Now we know that log of a by b is log a minus log b. So this ln s plus 1 minus s plus 5. This is f of s. Now if we take this derivative one time, what it becomes? S plus 1 log, we know the log x is 1 by x minus s plus 5. So if you put the minus sign here, this is reversed. Now we know that Laplace transform of t ft dt is equal to minus of 1 d of fs by ds. This is the one. So we can say that the t ft dt is equal to Laplace transform of Laplace inverse of this one. So its Laplace is e to the power minus 5t minus e to the power t, t ft. So ft is e to the power minus 5t minus e to the power minus t by t. So this question was asked for 20 marks, and we can see we are using this simple property, and here at n is equal to 1 we have done this question. Now I will take another question which is asked. Now the next question that we are going to take is we have to find the Laplace transform of t to the power minus half. This question is asked for 5 marks in Civil Services 2018. Alright, now we are going to solve this question. We know that Laplace transform of ft dt of any function is 0 to infinity e to the power minus st ft dt. Similarly, Laplace transform of t to the power minus half is going to be 0 to infinity e to the power minus st t half dt. Alright. Now we are going to put substitution. We are going to put st is equal to u. Okay. Now if we take its derivative, then it becomes s dt is equal to du. Hence dt is equal to du by ds. We are going to use it over here. And what is going to be t? T is going to be u by s. So Laplace transform of t minus half is going to be 0 to infinity, and e to the power minus st is our u, t is u by s, so it is half, so we can reverse it up, and what is dt? This is du by s. So we can take this s outside. We can see s is half, and then denominator it is 1. So what we get, we can take s by half outside. This is 0 to infinity. This is e to the power minus u, and u minus half du. No problem about this. Now this we must seek answer to this. This is basically gamma function. U, if we write minus half is half minus 1 du. This is gamma function. What is gamma function? Gamma function is factor gamma n is equal to 0 to infinity e to the power x, x and minus nx. So here n is half. So we can write it as 1 by s half, gamma half. Now we have got this answer. This answer is not complete. We know that gamma half is root s by half. So this is our answer. But the question is, if you do not know what the gamma function, gamma half is root pi, I will just illustrate in just 1 minute. Our claim is gamma half is equal to under root x. We have to prove gamma of half is equal to under root of pi. Sorry, not x. So we know a property, relation between beta and gamma function. Beta mn is equal to gamma m into gamma n divided by gamma m plus n. So if we just put beta half, that is going to be what? Gamma half divided by 1 plus half. So this is gamma half whole square. This is gamma 1 is 1 itself, and we have to find beta half. We know that beta mn is equal to 2 times 0 to pi by 2 sine 2m minus theta cos 2n minus half theta. If we put here half and half, if you put here half, 2 into half is 1, 1 minus 1 is 0. So sine 0 is 1, So this is your 1. So what we get rid of pi. So here root half gamma half ka whole square is pi. So gamma half is equal to root pi. So I think we have got the answer. Yes, root pi by s. And we have to show this if it is asked in more marks. If it is asked say for 15 marks, then we have to prove this relationship and find it. Thank you for watching this video. And like and share. And this is exclusively meant for civil services as well as other examinations, but particularly we are focusing on civil services questions. And like more and more, so that it can reach out to thousands of marginalized people or people who really want to study, having quality education on online medium. Thanks.